Hello, Mr. Price here, and this is the video on the multiplication for Year 7 homework. I'm going to quickly show you the answers for them, and then we're going to go through each one in turn. You can fast forward to the bits that you need most help with. Okay, here are the answers for the first ones. Okay, for A is 3, B 6 and 6, C 4, 12 and 4. Okay. For question 2, you could have chosen any of those answers in there and continue the pattern onwards. So you could have any one continuing on in 10s here, any number going up in 55s there, any number going up in 28s, and any number going up in 9s. Okay, and then it's what your Venn diagram might look like. Now I suspect yours might look a little bit different to that. In your learning response, if yours looks different to that, you'll want to look through that question. And same for this one. And then finally, the answer you were looking for the final one was 5040. Okay, let's go through each one in turn. Now, I'm not going to go through the missing number multiplication grid. However, I'm going to highlight that your likely mistake might involve the 0 column. Remember, if you multiply any number by 0, so 0 lots of 2, 0 lots of 4, 0 lots of 5, 0 lots of 10, they're all going to be 0. So just watch out for that one. Okay, let's have a look at part A. So we have the numbers 3, 6, 9, 12. Now I can see these are all in the 3 times table. Therefore, these are all multiples of 3, as they are all in the 3 times table. Okay, and obviously this pattern continues. Okay, now blank 12, 18, 24. Now I can see these are going up in 6s. So my missing number here is 6, so 6, 12, 18, 24. These are all numbers in the 6 times table, therefore these are all multiples of 6. Okay, couple of blanks this time, but I can see the pattern here. Something 8, something 16. I can see this is the 4 times table, so 4, 8, 12, 16. These are all multiples of 4. These are all numbers in the 4 times table. Okay, now this one is asking me to find a common multiple. Doesn't have to necessarily be the lowest, but any common multiple of the following numbers. So we've given an example here. 12 is a common multiple of 3 and 6, as it is both the 3 and 6 times table. Now, my best answer is going to be the one that's the smallest, but I'll go through each one in turn. So I want numbers in the 2 and the 5 times table, and if we wanted to, we could just list a few of them. 2 and 5, nope, 4 and 10, okay, nope. I'm going to keep on going with the 2 times table until I get to a number, 2, 4, 6, 8, 10. I can see that 10 is in both times table, so I'm going to have 10. If I continue the list going downwards, I might come up with 20, then I might come up with 30, etc. Okay, this one, going to write down the 4 times table and the 7 times table. So 4, 8, 7, 14, 1 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16. Okay, we've gone past 14 now. 1 7 7, 2 7s are 14, 3 7s are 21, 4 7s are 28. Okay, 4, 8, 12, 16, 20, 24, 28. There we are. I have a common multiple there, 28. Okay, alternatively, you could have also done 4 times 7, and that would have also given you 28. To find a common multiple, you can just multiply your 2 numbers together. Okay, with that pattern in mind, I'm going to use that for C. So, if I want a common multiple of 11 and 5, I can just do 11 times 5, which gives me 55. 55 is the 11th number in the 5 times table, and it's the 5th number in the 11th times table. So there's my answer, 55. You may have also come up with 110 or even 165. These are all numbers in both times tables. Now finally 9 and 3. This one's nice and straightforward because I already know that 9, beg your pardon, is in the 3 times table. So therefore 9 is going to be a common multiple. I can prove that now. 3, 6, 9. 9 is in the 3 times table. 9 is in a 9 times table. If you continue the pattern along, you'd eventually come up with also 18 or 27 and keep on extending it. Okay. Now let's have a look at section 2. This is more of an extension, but hopefully many of you tried it. Now I want to draw a Venn diagram for the multiples 2, 4 and 6. Now I suspect some of you might have drawn something like this. For maybe 2, and for 3 you might have even made it look like this. Okay, and then have a circle for the 3, 6 and 9, sorry, for the 2, 4 and 6 times tables. But because every multiple of 2 will also be a multiple of 4, and because every multiple of 2 will also be a multiple of 6, that means I can have one big circle for my 2's. Okay, and then I can have a circle inside it for my 4's, and another circle inside for my 6's. Okay, so any multiple of 2 but isn't a multiple of 4 or 6, I'm going to put here. For example, 2 is not in the 4 or the 6 times table, but it is in the 2 times table. 4 is both in the 2 times table and the 4 times table, so I'm going to put it in that circle. Okay, 6 is in the 6 times table and the 2 times table, but not the 4 times table, so that's going to go there. 8 is in the 2 times table and the 4 times table, but not the 6 times table, so that goes in a circle inside both. And then 10 is only in the 2 times table, it's not in the 4 or the 6 times table, that goes in a circle outside the 4's and 6's. And finally 12 is both in the 2 times table, the 4 times table and the 6 times table, so that goes in there. Okay, and you may have chosen to extend this along a bit further, but I'm going to stop there with those numbers. Okay, hopefully that makes sense. I put these circles inside the 2 circle because every multiple of 4 and every multiple of 6 will also be a multiple of 2. Okay, let's have a look at the next one. I'm going to draw a Venn diagram for the multiples of 3, 6 and 9. Now once again, because every multiple of 9 will also be a multiple of, because every multiple of 9 will also be a multiple of 3, and every multiple of 6 will also be a multiple of 3, I can draw one big circle for my 3's, and then put my 6 and 9 circle inside it. Okay, so 3 is a multiple of 3, but not 6 or 9. 6 is a multiple of 3 and 6, so that goes inside the circle of 3 and 6. 9 goes in here because it's a multiple of 9 and 3 but not 6. 12 goes in here because it's a multiple of 6 and 3. 15 goes here because it's a multiple of 3 but not 6 or 9. Now 18 will go in the middle because it is a multiple of 3, 6 and 9. And if you wanted to, continue that pattern even further. Okay, and now finally, I want the smallest number, which is in the 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 times table. Now, I can use my Venn diagrams to explain that if I wanted a number that's in the 9 and the 3 times table, I only have to worry about the 9's because every multiple of 9 will also be a multiple of 3. Likewise, if I've got the 10 times table, it will have every number in the 2 times table and every number in the 5 times table. Okay, I can multiply that by the 9's, and if I've got the 9 times table, I'll have every number in the 3 times table. If I have 8's, I'll have every number in the 8 times table and the 4 times table. Oh, and I'm sorry, I missed out the 6 times table as well from the 9's. And then finally, multiply the 7. And that will have every single multiple. Oh, sorry, that'll be the number in every one of these times tables. So, to work this out, I'm going to do 10 times 9 is 90. I'm going to put that underneath the 10 times 9 and bring everything else down. So I haven't multiplied by 8 yet, and I haven't multiplied by 7 yet. Okay, now I can do 90 times 8. Well, I know that 9 times 8 is 72. So 90 will be 10 times bigger, so 720 times 7. And then to do 720 times 7, I can do a very quick column method. 7 times 0 is no units. 7 times 2 tens is 14 tens. So carry that across, carry the 1. And then 7 sevens are 49, carry the 1, 50. So my answer is 5,040. If you need any further clarification from anything you've seen in that video, don't hesitate to come see me. Thank you very much.